The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
To work with a little bit of vector subtraction. Wonderful. We'll first take a look at, what are we going to take a look here? Let me just get my pointer here 1 second. Wonderful. We're going to use a graphical method to subtract the given vectors. Wonderful. So we see here that our first vector, remember how we just demonstrated a few slides back that how do we read this? This is telling us 2 meters in the x direction, right? And then in the positive x direction, and then 3 meters in the positive y direction. So we see here 2 meters, and then 3 meters, 1, 2, 3 meters. As such, that's going to give us the vector right there. Wonderful. Oh, that line is terrible, terrible. Not that that one's any better. Again, forgive me for the non-straight lines, but I really hope you're understanding the point here. Okay, great. Now, what about when we're subtracting vectors? Remember, we always do them tail to tail, right? So our next vector, what is it telling us to do? The notation here, it's telling us that it's 3 meters in the negative x direction and then 4 meters in the y direction. Thus, we can go 1, 2, 3, 4, works out to being about right there, right? And there we are. And our vector is going to be as such. Now, the resultant vector is just the difference between the two, right? And we can just go ahead and draw that in as such, right? There we are. Now, let's actually take a look at this and try to estimate the vector there, right? The resultant vector. Wonderful. And in doing so, go ahead and write the following, right? And that vector will say, firstly, what is the x value going to be? Well, where did we begin? Well, we're beginning here at 2, right? Because the reason we're beginning at 2, we're beginning here at 2 and we're going to -3, right? So the difference here is going to be -5, right? The difference between these two is going to be -5. Thus, we can say that this is going to be -5 meters, right? In the on the x-axis, right? And how about our y-axis, right? Well, we're beginning here at 1, 2, 3, and then we went up to, where did we go up to? We went up to 4, right? So the difference here is 1 centimeter, right? Thus, we can say that this is 1 meter, I meant to say. 1 meter, right, in the y direction. Wonderful. Now, we can also do this numerically, right, through the equation that we demonstrated earlier. So let's go ahead and take a look at that as well. I believe that was right here on slide 6, right, where we said that vector addition and vector subtraction graphically can be done. So we'll use the following equation here that we have to do vector subtraction, and we see that, just go back here, wonderful. Now, if we do so, right, and the formula here was just this x component, right, plus our the y component, right, as it was showing us. Well, let's go ahead and fill that in. Well, we know that the x component for the second vector, that was, what was that? That was -3 meters, right? Now, it was 2 meters for our first vector. Wonderful, wonderful. Let me actually just make this a little neater. Oh, that didn't work out. Wonderful, there we are. And now The y component was 4 meters for our second vector here, right? 4 meters minus the 3 meters. And there we are. And once we go ahead and we equate that, we see that we end up with negative 5 meters, right? And 1 meter here in the y direction. Thus, we see that our two expressions here, they are analogous, right? Wonderful.